Right now, everything around you feels perfectly still. Your chair isn't moving. The ground beneath your feet feels solid. But that's an illusion. Because at this very moment, Earth is spinning through space at over 1,600 kilometers per hour. Our planet is orbiting the Sun at 107,000 kilometers per hour. And the entire solar system is racing around the center of the Milky Way galaxy. Yet somehow, life feels calm, stable, and predictable. But the universe is full of forces that could change everything. Tonight, we're going to explore 4 cosmic scenarios that scientists often imagine. What if Earth suddenly stopped spinning? What really happens inside a black hole? What was the strangest signal ever detected from deep space? And finally, what if the moon disappeared tomorrow? Some of these ideas sound like science fiction, but every one of them is rooted in real physics. And by the end of this journey, you might see our universe very differently.
Right now, Earth completes one full rotation every 24 hours. That rotation creates our day and night cycle, but it also creates something else that we almost never think about: motion. At the equator, the surface of Earth moves at roughly 1,670 kilometers per hour, yet we don't feel it because everything on Earth is moving together. The air, the oceans, cities, mountains, and you. Everything shares the same motion. But imagine something impossible happens. Earth suddenly stops rotating. Not slowly, not gradually, but instantly. The planet stops, but everything on its surface does not, because inertia would keep everything moving. At the equator, that means objects would continue traveling eastward at over 1,600 kilometers per hour. That's faster than a commercial airplane. Anything not anchored to bedrock would be thrown forward violently. Buildings, vehicles, trees, entire cities could be devastated in seconds.
But the most terrifying force wouldn't be the land, it would be the air. Earth's entire atmosphere is moving along with the rotation of the planet. If the ground suddenly stopped, the atmosphere would keep moving. The result would be winds exceeding 1,500 kilometers per hour, stronger than any hurricane ever recorded, and stronger than any storm humans have ever experienced. These winds could scour the surface of the planet, flatten forests, rip buildings apart, and carry debris across continents. And then there are the oceans. Earth's rotation causes water to bulge outward around the equator. Without that rotation, the oceans would begin redistributing themselves. Water would surge toward the poles. The movement could create colossal mega tsunamis, walls of water hundreds of meters high. Entire coastlines could vanish under the crushing weight of the shifting seas.
But the disaster wouldn't end there. Earth's rotation also controls our day-night cycle. If the planet stopped spinning but continued orbiting the Sun, one side of Earth would face the Sun for months, while the other side would remain in darkness for months. The sunlit side could heat to extreme temperatures, while the dark side could freeze into deep cold. Life might only survive along a narrow band between these extremes, a permanent twilight zone around the planet. Luckily, physics makes such a sudden stop nearly impossible. Stopping Earth would require an unimaginable force, far greater than any natural event we know. But thinking about it reveals something important. Our planet feels stable, but it exists within a delicate balance of motion and gravity. And every second, Earth continues spinning quietly through space.
Few objects in the universe are as mysterious as black holes. They are regions of space where gravity becomes so strong that nothing can escape, not even light. Black holes form when massive stars collapse under their own gravity, compressing the core into an incredibly small region. The result is a gravitational field so powerful that it bends space and time itself. Around every black hole lies a boundary called the event horizon. This boundary marks the point of no return. Once anything crosses it, escape becomes impossible. But what would happen if you actually fell into a black hole? At first, you might not notice anything unusual. If the black hole were large enough, the gravitational pull at the horizon might feel surprisingly gentle. But something strange would begin happening to time.
To an outside observer, you would appear to slow down as you approached the event horizon. Closer and closer, your movement would seem to freeze, your image becoming dimmer and redder, eventually fading away entirely. But from your perspective, time would feel normal. Instead, the outside universe would begin accelerating. Stars would move faster, and galaxies would spin through the sky. You might witness millions of years of cosmic history unfolding in moments. But as you continued falling, gravity would begin stretching your body. Your feet would feel a stronger gravitational pull than your head. This difference creates tidal forces that stretch objects into long shapes. Physicists call this phenomenon spaghettification. Eventually, the forces become so extreme that atoms themselves could be pulled apart.
And then comes the greatest mystery. At the center of the black hole lies the singularity, a point where density becomes infinite and the known laws of physics break down. No one truly knows what happens there. Some theories suggest matter is crushed into infinite density. Others propose exotic possibilities like wormholes or new dimensions. Black holes also raise one of the greatest puzzles in physics, the black hole information paradox. Quantum physics tells us that information cannot be destroyed, yet black holes seem to erase everything that falls into them. Resolving this paradox may unlock a deeper understanding of the universe itself. Black holes are not just cosmic monsters. They are laboratories where gravity, quantum physics, and the structure of space-time collide. And throughout the universe, millions of them are quietly shaping galaxies.
In 1977, a radio telescope in Ohio called the Big Ear was quietly scanning the sky, listening for unusual radio signals coming from space. One night, something extraordinary appeared in the data, a powerful signal lasting 72 seconds. It was much stronger than background cosmic noise. When astronomer Jerry Amon reviewed the data, he circled the signal and wrote a single word: "Wow." Signal appeared to come from the direction of the constellation Sagittarius and occurred at 1,420 megahertz, a frequency associated with hydrogen. Scientists had suggested that extraterrestrial civilizations might use this frequency to communicate, making the discovery intriguing. Yet the signal never appeared again. Astronomers searched the same region repeatedly, but it was never detected a second time. The mystery remains unsolved.
Since then, astronomers have discovered another strange phenomenon: fast radio bursts. These are incredibly powerful radio flashes from distant galaxies that last only milliseconds. Yet in that brief moment, they release enormous amounts of energy. Some repeat, while others appear only once. Scientists are still working to understand what causes them: magnetars, neutron stars, or perhaps something even stranger. Tonight, step outside and look up at the moon. It has been Earth's companion for over 4 billion years, shaped after a massive collision early in our history. But imagine the impossible happens. Tomorrow morning, the moon is gone. No explosion, no debris, just empty sky. At first, life might seem unchanged, but the effects would soon begin. The most immediate change would involve the tides, as the moon's gravity pulls on our oceans.
Hopefully, without the moon, tides would still exist but would be much weaker, influenced only by the sun. Coastal ecosystems could be disrupted. The moon also stabilizes Earth's axial tilt. Without it, our tilt could vary dramatically over millions of years, leading to extreme climate shifts and unstable seasons. Nights would become darker, affecting animals that rely on moonlight for hunting. Even human culture would feel different, as the moon has influenced calendars and mythology for millennia. The universe is full of powerful forces working in a delicate balance. Imagining these changes reveals how our planet and the stability of our world depend on cosmic relationships. Somewhere in the vast darkness, there are still mysteries waiting to be discovered, signals we haven't heard, and questions we are only beginning to ask.